So, our group, meaning Kevin Rocha and Kobe Rogers, are doing the unit of probability. So, we're going to be looking at this top half right now. So, we have a wheel that has 4 colors: yellow, red, green, and blue. What is the probability of the spinner landing on red twice? So the probability of landing on red one time is 1 out of 4. And the probability of landing on red another time would be 1 out of 4. The same thing. You multiply these two probabilities and it would equal 1 out of 16. But how do we find out if it's independent or dependent? So independent is when the first action changes the second action. So let's say if we were to like pick out like, how do you say it? So if you were to like pick up a stick from a cup, but without putting the stick back. So let's say there's 8 sticks, and the probability of getting 1 stick is 1 out of the 8 sticks. All right, but then you pick out a stick another time. That would be 1 out of 7 sticks, since we didn't put that same stick back. That would be 1 out of 56. This is a dependent. And independent would be like this one, where these first two don't change.
So guys, back with another video. You know, my name is Kobe. I'm gonna be here explaining to y'all the probability of marbles in a bowl. So right here in this bowl, we got we have 8 blue marbles and 14 green marbles. If you draw 2 marbles without replacement, meaning if you take one out, there won't be one back in, what is the probability of A, drawing 2 green marbles in a row, B, drawing 1 green marble and 1 blue marble, and C, drawing 2 blue marbles? So A, with drawing 2 green marbles, it would be 14 out of 22, because there's 22 marbles total and there's only 14 green marbles. But if there's no replacement, then it would be 13 out of 21 for drawing the second green marble, which would add up to being 13 out of 33 as the probability of drawing 2 green marbles. B, drawing 1 green marble and 1 blue marble, would also be 14 out of 22 again, because there's 14 green marbles out of 22. And then if you multiply the blue marbles, which is 8, you would also have to take one out from the denominator, because 1 has already been taken out of the stack, which would result in 8 out of 33 is the probability. And for C, drawing 2 blue marbles out of the bowl of 22, it would start off with 8 out of 22, and then it would be multiplied by 7 out of 21, because you would have to take 1 out of both, which would equal 4 out of 33 is the probability. Yeah guys, gang, you already know, get at me.
So today we're gonna be solving probabilities of Venn diagrams. So right here we got a Venn diagram labeled A, circle A, and B, circle B. And we're gonna be solving the probability of these 4 questions. So the first question is the probability of A union B. Unions meaning that they're together. So we have A, 0.1 plus 0.2, 0.3. So boom, boom, and boom. We're gonna add these 3 together. It'd be 0.6. All right. And then for number 2, we got the probability of B and or intersection with A. This is meaning it's not like union where you put them together. It's where you find what B and you find a section of the Venn diagram that is both B and A. So right here we see that this is only A, this is only B, this is neither. Right here we find the shared part of circle B and circle A. So this would be 0.2. And now we got probability of A and B, but this is different. It's like a fraction where you put out of B, which is 0.5, how much of A is in B. So we see that B is 0.5, and we see that in B there's 0.2A. So it's like a simple fraction. So that would be the answer, 2/5. And now we got the probability of A union not B. So this little dot means it's not B, basically. So A union B would be A 0.1 and everything that's not in B, which is 0.4, basically. So it'd be 0.1 plus 0.4 equaling 0.5. So this is how you solve the probabilities of Venn diagrams.
It's Kobe back with another video, and here we're explaining the probability table. This shows out of 1,000 people who was at the pool or the park in one certain day, and if it was either a boy or a girl. So how we can convert this into a problem is we could do boys intersecting people at the pool. So what number of boys were also at the pool during this day? So if you cross of all the boys and who was at the pool, it's 250 people out of 1,000. So that would equal up to 1/4. 1/4 of the people were at the pool and were boys. So when you come to this problem, it's basically of all the girls who was at the pool. So it's not going to be out of the 1,000 people, it's going to be out of 400, because that's the total girls that was there. So 400 out of who went to the pool was 300. So the equation would be 300 out of 400, which would simplify to 3/4. And then of the union sign, it's all of the boys and who went to the pool. So all of the boys and everybody who went to the pool is going to equal 900, because the only people who was not a boy and who did not go to the pool is the girls who went to the park, which is only 100 people out of the 1,000. So the equation would look like 900 out of 1,000, which would simplify to 9/10. And yeah.
So we're gonna be shading in Venn diagrams of 3. Here we have A intersect B, union C, and here we can see A and the intersect of B. So it'd be this shaded region that intersects A and B. But we also have union C, meaning or C. So it'd be A, the intersect of A and B, or C. And we shade in all of C. So it'd be A, intersect of A and B, or circle C. And here we got another Venn diagram of 3, but this one states A union B, meaning out of this circle, what is not in C? This little dot meaning not in C, not in the letter. And then, so we have this shaded area already. It'd be this shaded area because it's asking out of A and B of the circle what is not in C, which would be these parts. So it cannot be these parts, and it'd be the remainder of the circle, A's and B's. So yeah.
So it's Kevin Rogers. Kobe Rogers, and we're doing the unit of probability.